So the idea is, let me wrap everything up again, and I didn't even finish the virtual work part. The idea is, when we have EA times d2u by dx square of x plus p of x equal to 0, so the idea is we can use the indirect integral equation. We can say u of x equals sigma over I u asterisk of x minus xi I times phi of xi I. So we represent the solution at any point u of x in terms of the fundamental solution. Or we can weight the solution as Paul like. We can say we get the same differential equation we have it here, weighted by another function, and we integrate over the domain, and we say this is the weighted residual statement, and we substitute it by 0. But in the weighted residual statement, we'll use this one as the fundamental solution. The solution for the fundamental solution. Instead of any function u asterisk, we can use u asterisk of x minus xi. So we will end up, after integration by part or weaken the differential equation, we will end up to very nice integral equation, which is u asterisk of x minus xi, as we said before, times f of x minus f asterisk of x minus xi times u of x. This is substituted between x equal to L and x equal to 0. Actually, this is a boundary integral. Okay? Minus u of xi plus integral from 0 to L p of x times u asterisk of x minus xi equal to 0. So this is the indirect integral equation, and we differentiate it with respect to x. We'll get f of x equal to sigma f asterisk of x minus xi I times the phi of xi I. If we, from these two equations, condensate I, eliminate phi of xi I, will end up to this equation. Actually, we had one paper only written by Professor Butterfield and Carlos Brebi. It's the only one paper written by these two guys in applied mathematical modeling. It gives you the equivalence between the direct and indirect form, how to condensate this phi to get this integral equation. Here we use this integral equation first at known boundary conditions. We use it at first at very boundary condition to get phi of xi I. Then we use phi I to get internal points at y equal any value of x, because we call it indirect integral equation. We got phi first, then we substitute to get internal points. We get u of x and f of x. Here we choose in this way, we choose xi to be the boundary points. To obtain the unknown values at boundary points first. Then we can choose xi at any internal point to get values of u and f at any internal point. Here, the boundary conditions in this part, in this indirect integral equation, the boundary conditions, we choose points. The boundary conditions are not embedded inside the integral equation. But here, the boundary conditions are embedded inside the integral equation. When we substitute at x equal L minus x equal 0, we will have the boundary conditions are substituted inside the boundary integral equation. Before I end up, I know I'm running out of time. Here, if we have domain load in the indirect integral form, we have to use the complementary solution and a particular integral. But here, The particular solution is here. This is a particular solution direct. So this is another definition of the particular solution. It's a forcing term times the fundamental solution. It comes from here. Okay? I'm sorry I didn't finish what I wanted to say because still I need to give example because these parts here I didn't show how to compute U asterisk of L minus L and F asterisk of L minus L and so on. So and still I didn't explain how to formulate the same integral equation, the same direct integral equation using better reciprocal theory or virtual work. Actually, it's very, very wonderful and very elegant actually. So if Paul allow me to have 1 hour, maybe in the next lecture or something like that, 1 hour more or something like this, I will be able to do this. Or I have to add, instead of the coming lecture to give it as lecture 3, we'll give it lecture 2 dash or something like that to continue this. I know it is very heavy. I know it is very heavy. I used to teach actually these 2 lectures at Cairo University actually over 4 hours actually. It's not over 2 hours. So at this point I have to stop because I know it is heavy, but by time things will come very, very easy at the end of the day.
Okay, thank you very much. And I think it's very clear.
I will leave it for Paul now.
Yeah, I think introduce the method by hand, and yeah, so it's very clear. I think that everyone will understand I think the idea of the fundamental
Yes.
of the BEM, and yeah. So anyone have the question?
If we have any question or something like that, and I promise that part 1 of the coming lecture I will revise all of these parts and I will give how to formulate the direct integral equation in using the virtual work. It is very, very elegant, and we'll use it for plate bending and for elasticity after that. If there is any question, I welcome any question. I hope people are not getting mad of me now, because they used to get mad of me.
But I think that it's very clear for each one, because you write it. And then
I'm crossing my finger, as they say in English. I'm crossing my fingers because
you're using the finger, not the pen.
No, I'm crossing my fingers. They say it is expressions. They use it in England that you hope for something or something like this. No, I use pen. I use this pen actually.
Yeah. Okay. So, I think it's very clear. Yeah. So, if no question,
next time I will revise this part. I will take the first part of the coming lecture as a revision for this part totally. Okay.
Okay. So, if no one have the question, so maybe we see you next week.
Okay. Thank you.
And I want to thank you for today's teaching. I think everyone want to learn the BEM, and it's very easy. Yeah. Maybe I will share this lecture to
I will send you
the committee in China.
Actually, Mr. Ibrahim with me, he's watching with me now. He's cutting this lectures to 10-15 minutes long, parts. I will upload it on YouTube, and I will send you this part so you can put it in China or anything. Again, I will write my number. I have WeChat on this number. It is 0020 12 7 7 866-833. If you want to send
Zhuojia.
Yeah, it is.
I will try to add you.
Yes.
Yeah, I'll try to add you soon.
So if anybody want to send me anything throughout the week, I will be happy and I will reply direct. I think Ibrahim was us. Just confirm, Ibrahim, that you are with us.
And yes, doctor, I'm here.
Yes, and you are trimming the lectures to 10 to 15 minutes long.
Okay. Yes, exactly. Yes, right.
Okay. Thank you, Professor, and thank you, everybody, and see you next week on the same time.
Okay, thank you, Professor Rashed, and thank you, everyone, to attend. Okay, see you next week.
Okay.
Yeah.
Bye.
Bye-bye. Bye.